We've come to understand how an atom with 2, 3, or 4 electron domains will form hybrid orbitals in order to make the necessary covalent bonds. But atoms can have more than 4 electron domains. If an atom has 5 electron domains, it will need to combine 5 atomic orbitals. So after it uses the s and the 3p orbitals from the valence shell, it will need to use a d orbital. So atoms with 5 electron domains are sp3d hybridized. The reason that only atoms in the third row of the periodic table and below can form more than 4 bonds, that is, form hypervalent molecules, is because an atom with more than 4 bonds requires access to d orbitals in its valence shell. The first set of d orbitals occurs at n equals 3. So elements in rows 1 and 2 do not have access to d orbitals, since 1d and 2d orbitals do not exist. That is why elements like carbon and nitrogen and oxygen so strictly follow the octet rule. Molecules like SF4, ClF3, and ClF4+ will exhibit sp3d hybridization and therefore trigonal bipyramidal geometry, as we can see from the way the electron domains distribute themselves. These may have a seesaw or T-shaped molecular structure, but the electron pair geometry is dictated by the number of hybrid orbitals, which are occupied by both bonding electrons and lone pair electrons. An atom with 6 electron domains will combine 6 atomic orbitals, the s, 3 p's, and 2 d's, to become sp3d2 hybridized. That means that molecules like SF6 exhibit sp3d2 hybridization and therefore octahedral geometry, which is evident from the way these hybrid orbitals distribute themselves. The number of electron domains that surround an atom will dictate the number of hybrid orbitals needed to house all the electrons, and the number of hybrid orbitals required will dictate the number of atomic orbitals that are needed to form them. This is why the number of letters found in the hybridization will match the number of electron domains around the central atom, from sp all the way to sp3d2, as these are the atomic orbitals that are available. Now we will practice assigning these orbitals to atoms in various molecules.